Hi students, welcome to Max Point of View. This video is based on Force Part B, Center of Gravity. This is a very easiest topic. Why? Because based on this one, in previous 5 years they have asked only one question, that too for 2 marks, and a very easy concept. They are going to ask you to find center of gravity for different shapes. Okay, and only one question that was repeated twice, that we are going to learn at the end. We need to understand what is center of gravity. Center of gravity is a point on an object where the algebraic sum of moments of weights is 0. I know you did not understand this one properly. I'll give you one example. Assume you take any object with any shape. Assume this is the center of gravity. Assume we don't know the center of gravity of this object, that we will learn how to find. We need to understand the meaning of center of gravity. Assume this is the point of center of gravity. What did I tell? It is a point at which algebraic sum of all the weights, moment of weights is 0. That means all the weights are acting at this point. Okay, whether it may be from downwards or upward, all the weights of this body will act on this point. At this point, the moment of weight is 0. Sum of moment of weight is 0. This is nothing but center of gravity. We can take the example of a textbook. Few students I have seen, they'll hold the textbook like this and they'll rotate right. At that point, all the weights are acting at that point. That is the center of gravity. That is a real life example. Now we will learn the complete thing about center of gravity. Center of gravity depends upon only one factor, that is nothing but shape. If shape changes, center of gravity also changes. I'll give you one example. Take an example of a wire. Okay, any wire you can take. Center of gravity will be the midpoint of this wire, correct? Now, if I make a circular loop using this wire, okay, like this, using the same wire, if I make a circular loop, okay, center of gravity will not be here, here, here or here. It will be exactly at the center, okay, somewhere here where there is no mass. Okay, so what this suggests, center of gravity depends upon shape. If shape changes, center of gravity also changes. You can also say, instead of using that word shape, you can also say distribution of mass of particles. If distribution of mass of particles changes, center of gravity also changes. You can use any one, shape or distribution of mass of particle. So this is the only factor which affects the center of gravity. Now we will learn center of gravity for different shapes. If we take an example of rod, okay, the center of gravity will be the midpoint of the rod. Now if we take circular disc, the center of gravity will be exactly at geometric center. What do you mean by geometric center? Geometric center is nothing but centroid, which we have learned in mathematics. Next, solid or hollow sphere, geometric center of the sphere or centroid of the sphere. Next, solid or hollow cylinder. Okay, see, you need to remember all these points because they may ask you any shape. You have to mention the exact words which is given in the textbook. So you cannot write something else, center point of the rod, all those things. Write the keywords which is given in the textbook, that is safer for you. For a solid or hollow cylinder, midpoint of the axis of the cylinder. Okay, next, solid cone at a height h/4 from the base on its axis. Next, hollow cone at the height h/3 from the base on its axis. Next, circular ring, center of the ring. That is what we learned, right? That I have told you in the example. Next, triangular lamina or scalene triangle, the point of intersection of medium. And after learning all the concepts from part B, we are going to solve each and every question which is there in the textbook. So we are going to complete everything, don't worry about it. Next, parallelogram, rectangular lamina, square or rhombus, all these are quadrilaterals, correct? For all these things, the point of intersection of diagonals. So these are the points, the position of center of gravity. You need to remember all these points, exactly where the center of gravity lies. See, in center of gravity concept, there are only 3 or 4 questions they may ask you. First thing is the definition of center of gravity, that you can answer right, I know. Then they will ask you the position of center of gravity for different shapes. Those different shapes they will only give. They'll ask you find the center of gravity for a rectangle or a triangular lamina or a sphere or a circular disc. Like this they'll ask. You have to write the position of center of gravity. That's it. And one question they have asked, I am going to teach you at the end. Now the final concept remaining is how to find the center of gravity of an irregular shape object. Irregular shape object, you can take any shape, okay, you can take any shape. So in this shape you can make 3 or 4 holes anywhere, okay. Make sure it is at the corner, at the edges. Now take a stand, okay, take a stand, and this stand should have 2 things. One, there should be a hook, okay, there should be a hook and one string, okay. This string is back side of this object, okay. This string is not coming through this hole, okay. Just this object is in front of the string and there is a hook, right? So now what we are going to do is make sure this object is attached to this hook, through any one of the hole, okay. You can take A, you can take this as A, this hole as B and this hole as C. Now what we are doing is we are attaching this hole A to this hook, and you have to make sure this is not moving, it should be stationary. Now now we have to compare this string, okay, the string which is back side of this object, okay, and we have to draw a line. Next we are going to rotate this object like this, and we are going to stick this hole to this hook. Now the point C, the hole C is attached to this hook. Now in the same way, once you are sure that this object is stationary, draw a line, okay, exactly straight to this string. In the same way you have to repeat the experiment using this hole B. Now once you got, see, through C you will get a straight line and through B you will get a straight line. Where these points are meeting, that point is nothing but the center of gravity. You got my point? Very easy experiment. You are going to make sure that this hole is attached to this hook and it should be stationary. Draw a line exactly straight to this string which is also stationary, and repeat the same thing through B and C. So once you got 3 straight lines, where they are, all the 3 straight lines are meeting, that point is the center of gravity. So this is how we find the center of gravity for irregular shape objects. This question was asked in the previous year for 3 marks. See, what is the position of center of gravity of a triangular lamina? See, this is very easy. Assume there is a triangle and you have to draw the medians, correct? Once you draw the medians, the point of intersection of medians is the position of center of gravity for the triangular lamina. This is for only 1 mark. See the second question. When the triangular lamina is suspended freely from any one of the vertex, what is the moment of force produced by its own weight in its rest position? in its rest position. So you need to understand the question properly. They are telling you are going to suspend this triangular lamina from one of the vertex. See, you need to know what is the vertex. See, these are the 3 vertex for the triangular lamina, and if this is suspended from one of the vertex, then what is the moment of force produced? What do you mean by moment of force? Moment of force is nothing but the rotation. Okay, when it is going to rotate, when it is fixed to a certain point, that is nothing but the pivot point. If this is fixed to a one of the vertex, assume there is a wall. Okay, assume there is a wall. This vertex A, you can take any vertex A, B, C. Assume we are going to fix this vertex to a wall. What is the moment of force? What is the rotation? Okay, we are going to see when it is at rest position. If it is at rest position, do you think there will be rotation? No, right? If it is at rest, there will be no rotation. If there is no rotation, there will be no moment of force. So what should be your answer? The moment of force produced by a triangular lamina when it is suspended at a rest position is 0. If you write just 0, you will get full marks. Okay, so this is the only question which was asked in the previous year, that is 2023, for 3 marks in the 5 years. And this concept, as you know, it is a very easy thing. First thing is you need to know the definition of center of gravity, then position of center of gravity for a different shapes, then this kind of question, and how to find the center of gravity for a irregular shape object. If you know these things, then you can answer any questions. Now we have learned all the concepts from center of gravity, correct? Now we are going to solve each and every question which is there in the textbook, and that video link is available in the description box of the same video, and videos of all the chapters will also be available in the description box. So chapter wise you can aram se go to that video directly.